In the vast symphony of planets orbiting our sun, there is one that stands out, a world cloaked in clouds of sulfuric acid, wrapped in a crushing atmosphere of carbon dioxide, and baked under a furnace-like sun. Venus, a planet so hostile, so utterly alien, that it has earned the name Earth's sister only by a twisted irony. Can this hellscape, this blazing, toxic world, ever be transformed? Could we rewrite the story of Venus? Could we terraform it, turning a world of fire and poison into a second home for humanity? Tonight, we journey to the hottest planet in our solar system, exploring the science, the dreams, and the daunting realities behind the quest to tame a world built by extremes. Venus was long a mystery, hidden beneath its thick veil of clouds, a world unseen to telescopes, only glimpsed through the eyes of space probes. Early speculation imagined lush jungles and oceans beneath those clouds. But as our machines reached it, the truth emerged. Venus is a world of extremes, surface temperatures soaring past 460 degrees Celsius, atmospheric pressure so intense it crushes metal like paper, and clouds laden with sulfuric acid droplets that rain down from a toxic sky. No life as we know it could survive here. The planet is a furnace, a pressure cooker, a world forged in the crucible of runaway greenhouse effect. Its landscape is bleak, a vast expanse of barren plains, volcanic highlands, and impact craters, baked and eroded over eons. The atmosphere is thick, over 90 times denser than Earth's, mostly carbon dioxide, with trace amounts of nitrogen and clouds of sulfuric acid. This atmosphere traps heat with staggering efficiency, creating a runaway greenhouse effect that elevates surface temperatures hotter than a pizza oven, hot enough to melt lead. The runaway greenhouse is the villain in Venus's story. Billions of years ago, Venus may have been more temperate, possibly even hosting liquid water. But as its young sun brightened, water evaporated into the atmosphere, amplifying the greenhouse effect, trapping more heat, boiling away oceans, and creating a feedback loop that transformed the planet into the hellish world we see today. This cautionary tale is not just a planetary curiosity. It holds lessons for our own world, warnings of climate change writ large in the cosmos. But despite its hostile nature, Venus has long been a tantalizing target for terraforming, the grand dream of turning a hostile planet into a habitable world. Scientists, engineers, and visionaries have imagined ways to transform Venus's atmosphere, cool its surface, and create a breathable environment. From giant sunshades orbiting the planet, reflecting sunlight and cooling its atmosphere, to chemical processes that could scrub carbon dioxide from the air, the concepts range from the fantastical to the theoretically plausible. Could these ideas work? What challenges stand in the way? And what would it take, not just in technology, but in human will and ethics, to terraform a world like Venus? To understand the scale of the challenge, we must first grasp the harshness of Venus's environment. Its atmosphere exerts a pressure over 90 times that of Earth's surface pressure. Imagine diving nearly a kilometer beneath Earth's oceans, and you begin to understand the crushing weight on Venus's surface. Temperatures hover around 467 degrees Celsius, enough to melt lead, and hot enough to turn steel to liquid over time. And then there are the clouds, sulfuric acid rains that constantly corrode anything unprotected. Any attempt to terraform Venus must grapple with these realities: pressure, heat, and chemical fury. Our understanding of Venus has been shaped by decades of robotic exploration. The Soviet Union's Venera program was the first to land on Venus, sending back the first images from its surface, brief but invaluable glimpses of a world no spacecraft had survived before. NASA's Magellan mission later mapped Venus's surface using radar, revealing vast volcanic plains and mountainous highlands beneath the clouds. These missions transformed Venus from a celestial mystery to a real, tangible place, one whose beauty is brutal and whose challenges are immense. Scientists today ponder the question, can Venus be changed? One idea is atmospheric scrubbing, removing carbon dioxide to reduce pressure and cool the planet. Some propose introducing genetically engineered microbes to convert CO2 into oxygen. Others suggest sunshades, massive mirrors in orbit, to reflect sunlight and initiate cooling. Yet each idea is beset by challenges. The sheer scale of Venus's atmosphere is staggering. Its mass is about 90 times that of Earth's. Scrubbing carbon dioxide on such a scale is daunting. The planet's slow retrograde rotation, spinning backward every 243 Earth days, adds complexity to any climate manipulation. Perhaps the future of humanity on Venus lies not on its scorched surface, but in its skies. At around 50 kilometers altitude, the atmosphere is temperate, the pressure similar to Earth's surface, and the temperature comfortable. Floating cities, vast, buoyant habitats suspended in the thick atmosphere, have been proposed as a way to live on Venus without terraforming the surface. This vision turns the challenge of Venus's environment into an opportunity, an alien but livable sky world, a new frontier for human exploration. Terraforming Venus is more than an engineering problem. It is a question of philosophy and ethics. Do we have the right to remake a world, to rewrite its natural story? What responsibilities do we bear in altering another planet, especially one that may have once harbored life? Venus's story challenges us to think deeply about stewardship, exploration, and the limits of human ambition. But before we can transform Venus, we must understand its geological and atmospheric history, the long, tumultuous saga written in rock and gas. Recent data suggests that Venus was not always the furnace it is today. Geological clues hint at volcanic resurfacing events, massive lava flows that reshaped its surface within the last few 100 million years, a mere heartbeat in planetary terms. Scientists have detected signs that Venus may have once held vast oceans, possibly deep enough to cradle life. This lost water, however, disappeared into the atmosphere, where ultraviolet light from the sun broke water molecules apart, allowing hydrogen to escape into space. The fate of Venus is a powerful reminder of the fragility of planetary climates and the delicate balance required to sustain life. Terraforming Venus requires monumental efforts to reverse the runaway greenhouse effect. One proposal involves sending fleets of solar reflectors into orbit, mirrors thousands of kilometers wide that would block or reflect sunlight, cooling the planet over decades or centuries. Another envisions chemical reactions to remove carbon dioxide, reacting it with surface minerals to lock it away as carbonates, or introducing engineered microbes capable of converting CO2 into oxygen. Yet the practicality of these solutions is hampered by Venus's hostile environment. Its heat, pressure, and corrosive atmosphere make even robotic missions challenging, much less human ones. Current and future robotic missions aim to unlock Venus's secrets. Missions like NASA's Veritas and ESA's Envision will map its surface with unprecedented detail, seeking signs of tectonic activity and past water. The Japanese Akatsuki probe continues to study Venus's atmosphere, revealing dynamic weather patterns and mysterious superrotating winds that circle the planet faster than its own rotation. Each new discovery adds layers to our understanding, painting a complex portrait of a world alive with geologic and atmospheric processes, albeit hostile to humans. But beyond science and engineering, terraforming Venus raises profound ethical questions. Is it right to alter an entire planet, perhaps destroying unknown ecosystems or prebiotic chemistry? Does our role as explorers and stewards grant us the authority to reshape worlds? These questions are not merely theoretical. They challenge us to consider our values, our responsibilities, and our future as a species reaching beyond Earth. While terraforming remains a distant dream, living in Venus's skies offers a tangible step forward. Floating cities, vast, self-sustaining habitats buoyed by breathable air mixtures, could house generations of explorers and scientists. Here, humanity could thrive in a world without oceans or solid ground, suspended in the thick, golden clouds, harvesting solar energy and studying the planet below. Such settlements might be the vanguard of a new age of exploration, a bridge between hostile alien worlds and human survival.